Shotgun ships with built-in workflow automations designed to speed up production. For example, once task templates are defined, they can be applied to many assets with a single operation, saving enormous amounts of time. And if dependencies are defined in those templates, adjustments to one task's schedule carry through to dependent tasks, again reducing frustrating and time-consuming human labor. Automations like these are super helpful, but every studio is unique and can benefit from additional custom automations. For example, maybe the modeling department would like to run a process on an asset when its status is set to done. Or maybe you'd like changes to an asset's cost to automatically bubble up to a global budget report. There are an infinite number of useful automations that can be imagined across unique industries and studios. So how do we extend Shotgun and create these custom automations? Well, there are several ways to do this, with AMIs, toolkit apps, scripts, but in this video we'll be focusing on what the Shotgun event daemon brings to the table. Before we dig in, you should know that this is not a video for beginners to Python or Shotgun. It's a good idea to watch the other videos in this training series first, unless you're already an experienced Shotgun developer who knows how to write efficient code. Otherwise, you could create slow event daemon plugins that decrease performance on your Shotgun site. To download the daemon, visit Shotgun software on GitHub, search for Shotgun Events, and clone the repo to the computer that will be running the daemon. In my case, I'll just run it off my laptop here, but in production, you'll want to choose a reliable server that you can access easily and that will, fingers crossed, be up all the time. Okay, let's take a look at the Shotgun Events contents here. All the goodies are in the source folder, so I'll open that up. First, I'll do a save as on the configuration file without the .example bit, and then identify a logs directory my user has access to. It looks like my user doesn't have permission to create folders in var log, so I'll just swap that out for my desktop. Take some time yourself to decide where you'd like these log and ID files to end up on your server. And don't worry about what the PID file and event ID file are just yet, we'll come back to those later. Next, change the logging level to 10. This will give you more verbose log output, which is good for developing or learning the daemon. You can switch it back to 20 sometime in the future, once you're more familiar with the daemon and its quirks. The next important bit is the Shotgun connection info down here. Swap in your site and provide a script name and access key. I'll create one for my site now, and then pop it in here. Once that's done, I'll set the path to the plugins folder. In my case, I'll also point that to my desktop, but again, you should take some time and decide where you want this folder to live. Some people put it inside the Shotgun Events repo folder, but I normally tell people to keep it somewhere else. That way it won't interfere with Git operations and Shotgun Events, and your plugin folder can become a Git repo in its own right. So that's the bare minimum you need to get started. We'll come back and check out the other settings later, but for now, let's fire up the daemon and see what happens. To do that, cd to the source folder and execute the Shotgun Event daemon.py file. Okay, we've got a few options here. If I go with start, the daemon will send output to log files, but nothing to the terminal here. Instead, I recommend using the foreground option when developing. Messages will still go to the logs, but they'll also be sent to standard out and show up in the terminal. Okay, first it looks like we need to create that plugins folder on the desktop. Let's try again. Now it's complaining about the Python API. If we go back to the GitHub repo and head over to the wiki, we can see that, indeed, the Python API is required. So I'll create a new virtual environment for the Shotgun Event daemon called sgdaemon virtual environment, activate it, and install the Python API into it. Now I'll try to start the daemon again. Great! Looks like we're getting a warning related to our empty plugins folder. So now we need a plugin. What else is in the Shotgun Events source folder here? So far we've looked at the configuration file and started up the daemon by running the Shotgun Event daemon.py file. Ooh, look! We've got some example plugins. That's helpful. I'm going to copy the logargs.py plugin to the plugins folder on my desktop. Now let's start up the daemon again. Cool, looks like the plugin is loaded. At this point, we can consider the Shotgun event daemon successfully installed. Let's move on and learn how to write plugins for it. Now that our logargs.py plugin is loaded, let's pop it open and take a look. First, I'll point out the two environment variables here. They expect another script key. Take a minute to grok the situation. The daemon itself needs a script key so it can query Shotgun for changes to the event log, but the individual plugins it fires off as a result of those events don't have to use the same script key. In fact, it's important that each plugin references its own script key. That way, event log entries in Shotgun can be attributed to specific plugins, and bad actors can be sidelined and debugged. Now I need to create the script key in Shotgun. Then export the environment variable in my shell. Cool, let's make this easier to read. For the demo, I'll pare down the code by removing the comments. Okay, so what's going on here? Well, the daemon looks at all Python files in specified plugin folders, which, as you remember, we defined in our configuration file. And if one of those files contains a register callbacks function, like we've got here, it will run that function. So what does that function do? Well, its main purpose is to run the register callback method that lives in the reg object. Reg stands for registrar, i.e. the official thing that registers stuff with the daemon. In our example here, we're passing in 1, a set of authentication credentials, 2, the name of a function, 3, an event filter that's currently set to none, and 4, optional additional arguments. A little further down in the plugin, you can see the logargs function referenced in the register callback call. So, in essence, this plugin's register callbacks function is saying, hey daemon, I've got this function called logargs that prints out some stuff, and I want you to run it with a specific set of authentication credentials whenever anything happens in Shotgun. And I mean anything, because the event filter is none. And that's it. So I'll check the terminal to make sure my plugin was reloaded and do something in Shotgun to see what happens. There we go. As an aside, let's go check out our logs directory. Remember, this is the directory we specified in the config file. Here you can see that the daemon created 2 log files, one for messages originating from our logargs plugin, and one for messages coming from the daemon. In practice, I rarely check these logs when using the daemon in foreground mode, like we're doing now, but later when we launch the daemon in start mode, these logs will be the only place messages are output to. At this point, you should understand how to download, configure, and start the daemon, and how to add and test the included logargs.py plugin. What next? Our logargs.py plugin here is pretty simple and mostly useless. It runs every time something happens in Shotgun and doesn't really do anything. So how do we make sure a plugin only runs when something specific happens in Shotgun, like if someone creates a new shot or changes an asset status? Well, we can accomplish that by modifying the 4th argument here, which is the event filter. Before I do that, why don't we make a copy of this plugin and call it demo.py, since we won't just be logging events anymore, and I'll grab a new script key from Shotgun and drop it into my environment. The event filter is a dictionary that contains key-value pairs, where the key is the type of event and the value is an entity's field or fields. Let's say we want the daemon to run every time anything happens to an existing asset entity. I can just type in shotgun asset change here. Done. But how did I know to do that? How did I know a change to an asset would be called shotgun asset change? To answer that question, let's check out the All Events page on our Shotgun site. If you haven't already created an All Events page, you can do it by creating a new page, setting the entity type to event log entry, and leaving the project field blank. Cool, so now we're looking at a record of everything anyone has done on our Shotgun site. Each tiny change users or scripts make is recorded here. So let's see what it looks like when I make a change to an asset. I'll leave this page open and navigate to my project's asset page in another browser tab. Okay, So that small change should show up on the All Events page. And here it is. Event log entities have a bunch of useful fields, but for now I'll draw your attention to the event type field. As you can see, the name of the event type is right here, so I can grab it and copy it into our plugin. Let's test this. I'll open the shots page in my project and make a change. Hopefully we don't see anything in the terminal. Oops, we do. Why is that? Right. You can see here that our logargs.py plugin is still active. It reported the change. Let's disable it by shutting the daemon down, creating a disabled folder, and moving logargs.py in. Now we can start up the daemon with only the demo.py plugin loaded and make another change to the shot entity. Great, nothing happens now. But if I make a change to an asset entity, bingo. A quick aside, the daemon can get confused if you disable plugins like I just did, by putting them into a folder and then taking them out later. A quick fix is to delete the event ID file here. Of course, that will blow away your event queue, but that usually doesn't matter during development. Let's get more specific. If I only want the plugin to run when an asset entity's status field changes, I can add the internal code for that field here. I'll change the logger message to give us a bit more info about what's happening. Don't worry if you don't understand this bit yet. Cool, it works. And if I need to target multiple fields, I can change this to a list. So now the plugin will run if the status or description field changes. I could also add another entry here for a different event type, maybe a shot change with the code field targeted. There should be enough flexibility in this event filter dictionary to capture the event or events you're interested in. And remember, if you're ever wondering how to filter for an event, just visit Shotgun, simulate what a user would do in the GUI to create an event log entry, and then check the All Events page for the event type syntax. For the rest of this demo, I'm going to focus on asset status field changes, so I'll revert these other bits. One last note before we move on. You can register more than one register callback function here. So, for example, we could just copy this block, change up the event filter, and then point to a different function in the file. Why would you do that? Well, if you've got very similar plugins and you want to share code without importing modules, you could consolidate them this way, sort of like overloading a function. In practice, it doesn't come up all that often. Don't be surprised if you only ever use a single register callback call per register callbacks function. Next, let's look at the demo function that our register callback method references. We already know that this function is run when an asset's status field is changed, but we haven't yet looked at the available SG, logger, event, and args argument variables. The SG object is fairly straightforward. It's an authenticated Shotgun connection object the daemon creates with the script key credentials that are passed into the register callback function up here. We can use it to run Shotgun Python API commands. Cool. Next, we've got a logger instance. This is what's sending info to standard output in the terminal, and to our log files. Let's test these two together. I'll search for a project on our site and spit it out with a logger. Great, it works. Remember to use this logger instance when you want to report anything. Don't use print statements or create your own logger instance. Next up, we have the event dictionary. Let's send it out to the terminal to see what's in it. I like to copy the output back into the plugin I'm working on, for reference. If you take a close look at the output here, you'll realize we've already got enough data to take action. Let's write a simple bit of code that updates an asset's description field when its status field is set to on hold. I'll use the register callback method's last argument to pass in a setting called target status. I like to define static variable settings in the register callbacks function instead of cluttering the function body. Pretty straightforward, right? Let's see if it works. Amazing! What's that feeling in your chest, you ask? That's adrenaline. Your heart is racing. You're starting to realize the daemon's potential. You're itching to write thousands of lines of code to impress your boss, your family, and friends. That's great. Now take a deep breath, try to calm down, and finish watching this video. If you stop now, you run the risk of wielding great power irresponsibly. Let's take a closer look at the event dictionary. We've got the field the user changed, the event type, when the event happened, the entity and project the event is linked to, some super useful albeit somewhat redundant metadata info, the user responsible for the event, a session UUID, and the ID of the event log entry entity. Pretty much everything we could possibly want to know about the event. But there is one bit of missing info, the event log entity description, which we can pull down easily enough by querying the event. There's an added bonus to doing that. We can verify that the event log entry entity still exists in Shotgun, and not just in the daemon's cached event backlog. So I'll do that here and bail if the event doesn't exist in Shotgun. But how would that happen? Shouldn't the event log entry always exist? Well, the event may not exist in Shotgun in rare cases, if the site is restored from a backup, for example, or if an admin goes out of their way to blow away event log entry entity records. What I'm doing here might seem overly cautious to you, but since the daemon literally scans for everything that happens in Shotgun every day, forever into the future, it does a pretty good job of running into any and every bad apple edge case, so we should try to account for them. You might want to think of this extra layer of paranoia as the first rule of Event Club. Don't take anything for granted. Just because the event dictionary came back nice and clean when we tested the daemon earlier, that doesn't mean it will come back clean each and every time the daemon processes an event. Thousands, hundreds of thousands, and potentially millions of events are processed monthly. Fan can hit the paddle without a creak. In the spirit of Event Club, you can see that I've used the dictionary get method to query for event keys, in case they're missing. And I've also made sure that if event ID ends up being none, that there will be no repercussions in the code. For example here, if the ID is none, the API will simply return none. And in that case, if the sgEvent variable ends up being none, then we bail. Any ideas about other info in the event dictionary we should be paranoid about? Let's go down the list. First, are we sure all the keys we're expecting exist? Let's check anything we might use and make some convenient variables while we're at it. Okay, those are bits of data I might want to use. If any of them come back as none, we bail. Next, are we sure the sgStatusList field is still in the asset schema? Surely I'm joking, right? Yes, that's a pretty extreme example of paranoia, but I'll add it in a check anyway for kicks. This schema check can be especially useful if your plugin acts on a custom field across multiple entities. It's quite possible an issue with the schema will crop up. And now that we've got the schema, we can check to make sure the hold status is a valid option. Cool. Next, are we sure our entity still exists? It may have been trashed, so let's query that again and bail if it's missing. We could also check whether or not it's been moved to a different project if that matters, but I'll skip that one. Gotta draw the line somewhere. Next, what about the current value of the attribute? For example, this event's metadata tells us that the status field was changed from ready to waiting. But that happened at a specific time in the past, and things may have changed since then. Seconds, minutes, or even hours can pass if a backlog of events builds up. Remember, the daemon processes events sequentially, and if the daemon was accidentally shut down, we could be talking days. In any of those cases, the value of the status field might not be waiting anymore, so our code should not assume it is, and we should requery Shotgun to verify any info we plan to act on. so I'll add a check for that here. Okay, I'm starting to feel a little better. We've built a little paranoid rampart to protect us from the uncouth maelstrom of events boiling in our Shotgun Sites database. Might as well clean up our original call to update the asset's description field. I'll point out a couple strategies in the code here before we move on. You'll remember my copious use of the get method up here to avoid key errors. Take a look at the way we used it with new value. If you're going after nested keys, remember to default the parent keys to an empty dictionary, or you'll get an attribute error. Finally, you may wonder what the performance impact of these validators is. I encourage you to test and time your plugin to make sure the benefits of the validators aren't outweighed by performance hits. For what it's worth, I'd stand by the code I've written here unless someone proved to me this plugin was running literally all the time and these checks affected performance. Then I might remove them to speed things along. Or I might try to move some of the validators to the register callbacks function. That way they'd only run once, when the plugin was loaded, instead of every time the plugin was triggered by an event. Can we do that with any of the checks I just wrote? Aha! Let's try it with the asset status field schema check. I'll cut and paste it out into its own validation function called isValid, and then call it from register callbacks with a dedicated shotgun handle. Here's an additional benefit of putting validators in the register callbacks function. They run when you load the plugin, so issues with the plugin crop up right away, and we can even decide not to register the callback at all if the validation fails. I'm also going to take the opportunity to refactor a bit here. Don't worry if you don't follow all of this. The code in this demo.py plugin is available for download, so you can take a closer look. Okay, now let's create something that might actually be useful. We've already got a plugin that fills in an asset's description field when that asset's status field is set to on hold. Let's extend our plugin. Let's get all the tasks linked to that asset and set their statuses to on hold too, unless they're already set to final or NA. I'll need to run multiple update commands to accomplish this, so I'm going to initialize a batch data command list and change this update call to be part of it. Next, if we're going to update task status fields, we should make sure the sgStatusList field is in the schema. Again, this is super paranoid, especially since it's impossible to delete this field from the GUI, but I'll do it here anyway as an exercise. If it was a custom field that didn't exist on all entity types, this check would make more sense. After that, we can pull down all the tasks linked to the entity and log an update request with our batch data list. Remember, we don't want to change tasks set to final or NA, so I'll add another setting for that. Maybe I'll call it skip statuses, and then skip tasks set to those statuses. Cool, almost done. Finally, we can pass our batch data list to an sgbatch command and tell the logger about it. Let's see if it works. Great, just what we expected. Let's check the output in the terminal. Cool. So now we've got a plugin that filters for specific event types, validates relevant schema fields and incoming events, checks field data for expected values based on the event, and finally, if everything looks right, it performs a little automation with the Shotgun Python API. I'll leave it up to you to judge whether what we've created here would be helpful in your production. Personally, I would only use a plugin like this if I had a lot of small assets in Flux, whose many tasks were distributed across remote artists and my producers were spread thin. If, instead, assets at my studio were infrequently put on hold, I'd prefer to trust my producer to manage the statuses and message out changes personally. But that's just me, and of course you're in complete control and free to decide what your custom automation should or shouldn't do. Writing daemon plugins is a bit of an art, and the best way to learn is to write a few. Finally, I'd like to say that I believe I'm overly paranoid for a good reason. After writing a large number of event daemon plugins, I've seen about everything go wrong that can go wrong. I wouldn't necessarily run so many checks in, say, a Toolkit app or a standalone script, but the daemon-related coding habits I'm passing on here are hard-won. Of course, maybe you think this plugin is overly complex, and every developer is free to walk his or her own path of many lessons. Far be it from me to keep those lessons from you. Earlier, I removed all the comments from the logargs.py file so we could focus on the code. Of course, it's imperative that you comment your code, and I'll review some best practices for doing that now. First, it's a good idea to leave a bit of information at the top of the file, so other devs can open it up and quickly grok what the plugin does and how to use it. Next, let's leave standard Sphinx-style docstrings for each of our functions, along with info about the parameters and return types. Cool, done. That might seem like a lot of work, but it'll really pay off in the long run. You'll get auto-generated documentation for free. If you get a Sphinx instance spun up, other developers will be able to read and review your plugins much more easily, and the comments will help you clarify for yourself what the plugin should do. Next, it's time to give our callback function and plugin a more appropriate name. I'll call them both asset status update task status. They don't have to share a name, but many times do. Cool. Okay, let's head back to the daemon config file. Once you've got a plugin you believe is useful to your production, and you plan to just leave the daemon running, it's a good idea to enter at least one email address down here at the bottom. That way, if something goes wrong and your plugin starts throwing errors, folks will get notified by email and can address the issue. I'll use my Gmail account. Finally, shut the daemon down and launch it again in start mode instead of foreground mode. That way you can close the terminal and know the daemon is still chugging away behind the scenes. If you need to stop the daemon, just pop open a shell and run the stop command. At this point, you might as well kick up your feet, let the daemon do all the work, and just wait for your next paycheck. That'll probably work for a week or so, but eventually you'll probably run into a situation where a specific plugin crashes on a weird event. You'll get an email when that happens. Or you want a specific plugin to reprocess old events. So how do we do that? Well, remember that ID file we pointed to earlier in the config file? This little file stores 1. A list of plugins, 2. The ID of the last event each plugin processed, and 3. The backlog of events the plugin still has to process. So, by manipulating this file, we can effectively fast forward or rewind specific plugins to an exact point in the event log history. If you're looking at this file and thinking, WTF is this, then you're likely not familiar with the Python pickle file format. No worries, I'll show you how to load up the ID file in Python and make some changes. Start by making sure the daemon is shut down. Next, fire up a Python session, import the pickle module, and use it to load whatever is in our ID file. Cool. Looks like we've got a dictionary of stuff, organized by plugin paths. In our case, I only specified one plugin path, so I'll just grab that and toss it in a dictionary called desktop plugins. Let's see what we've got in here now. Looks like 2 plugins. If I pop them open, we get a tuple with 2 bits of information. The first is the ID of the last event log entry that plugin processed, and the second is a backlog dictionary of events the plugin still needs to process. Most of the time, you'll be in a situation like this, with an empty backlog, where you'll only need to modify the ID. So let's do that. For kicks, I'll rewind our logargs plugin 2 events into the past, and I'll fast forward our entity status update task status plugin 2 events into the future. Now I can just dump our changes out to the ID file, and we're done. Let's see what happens when we fire up the daemon. Cool, exactly what we wanted. The logargs.py plugin reprocessed 2 old events, and the entity status update task status plugin is telling us it won't process any events until this one is passed. That's it. A bit messy, but super useful in a pinch. And if you get good at grokking the ID file, you could just edit it manually, but make sure to make a backup first. Over the years, employees at Shotgun have built a variety of general use plugins for the Shotgun event daemon. Many were donated to clients and have enjoyed a long life doing battle and productions at some of the largest studios in the world. That is to say, many of the plugins in the example plugins directory here have been code reviewed, battle tested, and proven in production, and may be of use to you out of the box. I want to note, however, that they are not part of any Shotgun product, and should indeed be considered examples. We may not offer support related to them, even if there are bugs. So if you use one or more of these plugins, it's up to you to maintain and modify them as needed. Let's take a quick look at how to install one of them and change its settings. First, I'll browse to the plugin docs in GitHub. Most have a little animated GIF that will give you a quick idea of what the plugin does. This one is pretty useful. It sets a field to a value when another field, actually it could be the same field, is set to a value. For this demo though, I'm going to grab the DateStamp plugin. I've got a little description of its input parameters here that I can use for reference. Cool. So now, all I have to do is copy it from the examples folder to the plugins folder that I specified in the config file. Now let's pop it open and take a look at the arguments. Okay, it looks like by default, the plugin acts on shot entities. When the status field is set to fin, the SG file on field is stamped with the current date and time converted to Pacific time. And it looks like once the date is set, it won't be overwritten. Let's change this up a bit. I'll expand the trigger to work on assets, since they also have an SG status field, change the status we're looking for to omit, and change the field to SG omitted on. I'm on the East Coast, so how do I get correct time zone syntax for that? I'll head back to the doc to see if there's a clue there. Ah, it wants a PYTZ time zone. So if I Google a bit, I can quickly track down what I'm after. All set. Now let's try it out. I'm getting a key error related to our authentication. Right, I forgot to add a script key for datestamp.py to my Shotgun site. All set, let's try again. Oops, looks like our validator is saying omit isn't a valid status. I just need to change it to OMT. Now what? It looks like I need to add an SG omitted on field to the shot entity. That's probably also true of the asset entity, so I'll add those fields now. Lucky those validators were there to help fix my arguments. Great, the plugin loaded. Let's test it out on shots. And now assets. Very cool. You can see how flexible this plugin is, how the plugin file could be duplicated, given a different name, and different arguments. Of course, the same is true of most of the plugins in the examples folder. Although there are only 25 or so plugins here, their arguments could be configured to handle hundreds or thousands of use cases. Of course, they're also a great reference for building your own unique daemon plugins from scratch. In this video, you learned how to download the Shotgun Event daemon from GitHub, how to configure it, start it, write plugins for it, and modify the example plugins for use in your studio. That should be enough to get you started. But if you run into issues, check out the GitHub documentation wiki. There are more detailed instructions for managing the configuration file, troubleshooting tips, and discussion about the daemon's inner workings.